So this is the treatment plan for an upper central tooth number 8. As you could see, rendering the DICOM 3D, we could see the facial bone and the palatal area where the nasopalatine nerve is. This is the sagittal slice that we are looking at, and in moving the sagittal slice from the central point all the way to the right, we could see the bone in the sagittal slice right there where the cursor is showing. We have a very decent buccal lingual width of the bone, and so as a result, I would say we have sufficient bone to place a nice implant, but maybe we would not drill the site. We would use the osteotome to expand the site and place a nice implant in there. One other thing is the quality of the bone here on the extraction site of tooth number 8 is not the best, so augmentation with some bone grafting material is probably necessary. In this segment we will show the importance of taking an upper and lower full arch PVS impression, so we can look at the occlusion and we can look and segment the teeth and look at the load vectors and so on. So if we take, for example, the upper impression, once the upper impression is scanned and digitized, here we go. This is a 3D image of it. It will the software will render a positive model from it. Same thing is going to happen to the lower full arch PVS impression. Same thing, we will digitize it from the negative, which is the actual impression. We will turn it into a positive. We will put a base to it so we can actually print these models and articulate them. And then, of course, to articulate it, we also scan the impression, digitize the impression as well, and from the analysis of the digitization of the bite, we can look at the 3D analysis of the occlusal space. In the segmentation process, we will go ahead and basically segment the two adjacent teeth, in this case tooth number 7 and tooth number 9, and by doing that we will be able to segment the actual teeth from the tissue, and we will be able to look at the tissue segment alone versus the teeth segment, and we'll be able to look at the root form and at the CEJ of the teeth and what the tissue should look like. Once we do that, we can go ahead and actually go through the root segmentation process and go to the next level. So once we do the tooth and tissue segmentation, it's time to do the root segmentation and fuse the roots and the teeth together in the tissue. So now we can separate everything that we will look at. Now we can look at the teeth and the root segmentation, and we can look at the tissue segmentation as well at the same time. And from now, of course, if we're going to make a decision on where to place tooth number 8, we can take tooth number 9 now and mirror image it and place it into the tooth number 8 position. Now this is the most powerful part of the software. We will be able to take tooth number 9, mirror image it and position it in tooth number 8. We will not only be mirror imaging and positioning the tooth, but we will be able to mirror image and position the root as well. So technically we will have a good idea of where the occlusion is going to be exactly and where the root form, the CEJ relevant to the tissue, will be. Now if we go ahead now and look at the tissue, we can see whether we have enough papilla there. In this case there is the diastema that we're going to take into account, and then we will look at the actual occlusion relative to the position of the implant and the tooth and how we're going to be loading the actual implant in there. So here if we look at it, you could see that the tooth load vector has been calculated by the software. We can evaluate the occlusion as the mandible hits it from the lingual area and where the resultant load vector is going to be in the bone. On a natural tooth, of course, the tooth is positioned to the buccal. So now that we reverse engineered the tooth and the root relevant to the bone and we have the resultant load vector, the software will automatically snap the implant into the load vector area, and here you could see the tracing of the tissue versus the bone and the implant there in the bone, and you could see that the implant is very well positioned into the load vector. And now of course, by looking at it buccal, lingual, mesial, distal, and evaluating the relevant position of the implant to the roots, we can look at the load as the mandible will load it into centric, and we can also look at the position of the tooth that's in there. Notice that the access hole is coming right out of the buccal. In order to do a cement retained crown here, you'd have to do a separate abutment and a cement retained crown on top. You cannot do a screw retained restoration without using an ACH channel from Nobel Biocare or an angled abutment. I recommend the cement retained restoration in this case. Removing the slice through, you could see the tracing of the bone all the way around, relevant to the bone, to the implant. You could see the tracing, the pink tracing of the tissue, the load of the mandible as it loads that tooth, and the perfect positioning of the implant in place. So look at the slicer now. We can evaluate mesial distal bone as well by doing what we call the spinner slice, and as we spin the slice through, we could see the bone as the spinner goes in 360 degree around the implant pretty much. Once we get to the mesial distal position, we can evaluate the position of the implant right there, relevant to the roots of number 7 and roots of number 9. You could see the optimal position relevant to the subnasal plate as well. Then you continue the spinner as you go around the implant 360 degrees. Evaluate buccal lingual bone, evaluate the nasopalatine area of the bone, and you could basically run a 360 degree analysis of the actual position of the implant. There is no way in heaven we could do this with freehanding an implant, or even any other software that's on the market will not enable you to take a look at this kind of views that we have in the software. Now we load the surgical guide, which is actually the tracing in green, and the surgical guide will enable you to actually look at the relevance of the implant as it goes through the actual surgical guide into the bone. Here is the surgical guide, which is the green snapping onto the tissue, and you could see the actual implant, which is going through the regular platform sleeve of the surgical guide, which is the tracing in green. Notice the tight fit of the surgical guide to the tissue and the teeth adjacent to it. It has a perfect snap, and it'll give us a perfect emergence profile for the abutment, which is the actual tissue, the pink that was just removed. Notice the red implant relevant to the bone, buccal lingually, and relevant to the surgical guide, as you could take a look and evaluate it 360 degrees, again relevant to the surgical guide. This just takes us to the next level to show that freehanding dental implants nowadays in any dental practice should be prohibited, because there's no human being that will be able to duplicate the accuracy of positioning these implants with the surgical guides and using the CT scans, as you can see it right here. Finally, if you remove again the cross slicer and look at the safety zone that the system traces around the implant, it tells you the amount of bone that will be needed to be augmented to the buccal and the lingual around the implant. And in this case, you could see the green zone around the implant, which is the actual bone that will be necessary to get good osseointegration. So you'll use a 2mm drill, use the osteotomes, pack some more bone in there, and then drop the implant in there, and this will be done. This should conclude the treatment plan for this case.